In this video, we're going to look at how to balance chemical equations. Chemical equation is a way for scientists to communicate that a chemical change has occurred. Now, how would you know if a chemical change has happened? There are several different sorts of indicators of chemical changes. The first one that you're probably familiar with is you might get a change in colour. You might also have a change in temperature. You could have a precipitate occurring. Remember, a precipitate is a solid that falls out of solution. You might also have a gas evolving. Now, if there was a gas evolving, you'd be looking for bubbles. Now, all chemical equations are written in the format of reactants are converted to products. All chemical equations must obey the law of conservation of mass. Now, the law of conservation of mass says that matter cannot be created nor destroyed, but only changed from one form to another. Now, the consequence of this is that if you started with 50 grams of reactants, then you will finish with 50 grams of products. If you start with 100 grams of reactants, you will finish with 100 grams of products. So matter cannot be created nor destroyed. So what you start with, you've got to finish with, but it will be in a different form. Now, in order to write a correct equation, you must follow the following steps. First step, you have to write correct formula. If you don't write correct formula, you're doomed from the start. So always write correct formula. Now, the formula are dictated by valence. So if you don't know your valencies and can't write a formula, you're in trouble. So once again, learn your valencies. Now, you also must have state symbols. So if a substance is a solid, then you write the subscript S for solid. If the substance is a liquid, then you write that it is a liquid. If your substance is a gas, then you write gas. Now, if the substance is dissolved in water, it makes it an aqueous solution, and it has the state symbol AQ. Now, state symbols are very, very important, so you must write them. The third step is you are not allowed to change formula. So in order to balance, you must use coefficients. These are numbers in front. So if you wanted to have 2 magnesium oxides, then you would put a 2 in front. You are not allowed to change formula. In order to work out the coefficients, here is a series of steps which will allow you to do that. First of all, balance the metals. So magnesium, calcium, copper. Balance these ones first. Then balance polyatomic ions. Polyatomic means poly means many atoms in an ion. For example, sulfate is a polyatomic ion, as is carbonates. So balance those next if they haven't been broken up. It's easier to keep them as a group. The third step is balance non-metals other than carbon, hydrogen, oxygen. And the fourth step is balancing carbon, hydrogen, oxygen alphabetically. Now let's try an example. Magnesium metal reacts with oxygen gas to give solid magnesium oxide. So step number 1 is correct formula. So magnesium plus oxygen gas, which is O2, goes to magnesium oxide. Now, I had to work out magnesium oxide by using valencies. So, what do I know? I know magnesium metal is a solid, so I put in solid. Oxygen gas is a gas, and magnesium oxide is a solid. So I've put my state symbols in. So I've done step 2. Step 3 is to balance using coefficients. Now, in order to balance, remember we start first with metals. The only metal I have here is magnesium. So I've got 1 magnesium on the reactant side, and I've got 1 magnesium on the product side. They're balanced. Fantastic. Now, there are no polyatomics here. So next step, go to non-metals other than carbon, hydrogen, and oxygen. Well, there's no other non-metals, so our only other non-metal is oxygen. So let's have a look. On this side, we've got 2 oxygen atoms, but on this side, we've only got 1. Now, I'm not allowed to change formula. Formula is dictated by valence. So, the only thing I can change is by putting a number in front. These are called coefficients. So I put a 2 in front here. This means that I've now got 2 magnesium oxides, i.e. here's 1 magnesium oxide, here's a second magnesium oxide. So this means that I've now got 2 magnesiums and 2 oxygens. Voila, our oxygens are now balanced, but the problem now becomes that our magnesium is not. So on this side, on the product side, I've now got 2 magnesiums, whereas on the reactant side, I've only got 1. So I need to put a 2 in front. I'm not allowed to change formula. Now I can see I've got 2 magnesiums and 2 oxygens. It's balanced. Tick, tick. You should never get these wrong. Now let's try another example. Calcium carbonate is added to hydrochloric acid to give a solution of calcium chloride, water, and carbon dioxide. Step number 1, write correct formula. So calcium carbonate plus hydrochloric acid gives calcium chloride plus water plus carbon dioxide. Step number 2, I have to put in correct state symbols. Well, calcium carbonate is a solid, so I write solid. Hydrochloric acid means it's dissolved into water, so I write aqueous. Calcium chloride is a solution, so I write aqueous. Water is a liquid, so put liquid, and carbon dioxide is a gas. Step number 3, balance using coefficients. Now, in order to do that, I'm going to go through my steps. The first step is to balance the metals. Now, I've only got 1 metal, and that's calcium. So I've got 1 calcium on the reactant side, and I have 1 calcium on the product side. Now, step number 2, balance polyatomics. Now, carbonate is a polyatomic, but it's not on the product side anymore, so it's broken up. So I'm going to have to balance it broken up. So there are no polyatomics I can balance here. Step number 3, balance for non-metals other than carbon, hydrogen, and oxygen. On this side I have 1 chlorine, and on this side I have 2 chlorines. So in order to balance this, I need 2 chlorines on the reactant side. I can't change the formula. I can only put a number in front. So now you can see I've got 2 hydrogens and 2 chlorines. So chlorine is now balanced. Next step, balance for carbon, hydrogen, and oxygen alphabetically. So let's start with carbon. On this side I've got 1 carbon, and on this side I've got 1 carbon. They're balanced. Next step, balance hydrogen. On this side I've got 2 hydrogens, and on the product side I also have 2 hydrogens. So they're balanced as well. Next step, balance oxygens. On this side I've got 3 oxygens. On this side I've got 1 plus 2 is 3 oxygens. So this equation is now balanced. Give yourself a tick. Now let's try another example. Cobalt 2 chloride solution is added to sodium phosphate solution to give sodium chloride solution and cobalt 2 phosphate precipitate. So we need to write correct formula. So cobalt 2 chloride, add sodium phosphate, gives sodium chloride plus cobalt phosphate. It's really, really important to have correct formula. If you ever find yourself in a tennis match going from backwards and forwards, backwards and forwards, backwards and forwards, always check your formula. So, second step. Now we need to put in our state symbols. So cobalt 2 chloride is a solution, so it is aqueous. Sodium phosphate is a solution, which is aqueous. Sodium chloride is a solution, which is aqueous. And cobalt phosphate is a precipitate, so it's a solid. Now, balance for metals. So let's have a look at which metals. I'm going to start with cobalt. So there is one cobalt atom here, and there are 3 cobalts here. So I'm going to put a 3 over here. So that gives me 3 cobalts. Now I'm also going to look at my sodiums. So I've got 3 sodiums on the reactant side, and on the product side I've got 1 sodium. So I'm going to put a 3 in front here. Remember, you can't change the formula. Now it's time to look at the non-metals, which are polyatomics. So there is one phosphate, and this polyatomic, notice the phosphate is on the same, it reoccurs on the other side. It's easier to keep it in a group. So there is one phosphate on this side, and there are 2 phosphates on this side. Okay, so I'm going to have to stick a 2 in front. Remember, I can't change the formula. So I'm going to stick a 2 here. Uh-oh, that has changed the number of sodiums. Now I've got 2 times 3 is 6 sodiums. So I'm going to have to come across here and change how many sodiums I've got here. So I can't have a 3 anymore. I'm going to have to change it to a 6. So I'm going to go cross that out, or rub it out, and this time I'm going to put a 6 here. That now means I've got 6 sodiums. Now let's check our chlorines. I've got 3 times 2 is 6 chlorine. And on this side I've got 6 chlorine. So it is balanced. Give myself a tick. Now it's time for you to try some yourself. Go to the OneNote, Chemistry Unit 1, Reactions, Balancing Equations 1. Now there's lots there, just mostly to practice the third step. So try 4 or 5 and we'll go through them tomorrow.